Hello there. Let us discuss how can we extract digits from the number starting from first to last. Now, before I get started with this, let me tell you that this is not the more commonly used approach. The more commonly used approach is extracting digits from last to first, which I have already covered, and you can access that video by clicking the card that is appearing over here. Now, on to this. To understand how to extract digits from first to last, let us take a number and let's understand what can we do with this to get all the digits from first to last one by one, right? So if we have a number, let's say 1234, what will we have to do is we'll have to take the first digit. Now we will get to how in a moment, but for now, let's understand that we will have to take the first digit somehow, right? And then we will have to get rid of that digit. And if we do that, we will get 234. Now, if you ask, why do we need to get rid of the first digit? My answer is because we are extracting the first digit, right? So if I don't get rid of the first digit, then I'll have to figure out a way to get the second digit now. But if I get rid of that digit, I have to stick to the same logic, that is getting the first digit only, right? So if I get the first digit from here, I get 2. And then if I get rid of the first digit from this, I get 34. Then I get the first digit from here, which gives me 3. Get rid of that, you get 4. And then get the first digit and the only digit in the number, that gives you 4. And then you reach a point where there's no more digit left. And when that happens, you stop, right? So if you go by this logic, you will get all the digits of the given number one by one, starting from the first digit to the last digit. So this is how we can solve it using pen and paper. But the next question is, how are we going to solve this using programming? So let's understand that. Now, if you're familiar with how to extract digits from last to first, you would know that we do that by dividing the given number by 10, right? So if we do this, we get 123 as the quotient and 4 as the remainder. This 4 over here is the last digit of the given number, and this 123 is the number on which we operate on in the next cycle, right? So we go for 123 by 10. That gives us 12 as the quotient and 3 as the remainder. So this 3 is the last digit of 123, but it's the second last digit of the original number, right? So if you continue this way, you get all the digits of the given number from last to first. Now, can we use something similar to get the digits from the given number from first to last? We can. We can use division, but of course, dividing by 10 won't help. So with this knowledge, that is using division to get digits from first to last, let's figure out what will we have to divide the given number by in order to get the first digit. So for that, let me first of all clear this and let's think. If we have 1234, what do we want is, we want 1. And similar to what we do in extracting digits from last to first, we also want 234, right? So we want this as well. Now, what can we divide 1234 by, which gives us 1 and 234 both? Can we divide 1234 by 1000? We can, right? This will give us 1 as the quotient and 234 as the remainder, right? Now, if we take this 234 and we continue with this, we will have this 234. Now, at this point, what we want? We want 2 and we want 34, right? So, we want 2 as the quotient and 34 as the remainder. For that, can we divide 234 by 100? We can. This will give us 2 as the quotient and 34 as the remainder. Now, if we take the remainder, which is 34 here, and continue with that, what do we have? We have 34 and we want 3 as the quotient and 4 as the remainder. And we can get that by dividing by 10. Now, if we continue this way, we have 4 and we want 4 as the quotient and 0 as the remainder. So if we go for 4 by 1, that will give me 4 as the quotient and 0 as the remainder. And when we reach 0, there's no point continuing, right? Because we have exhausted all the digits that were there in the original number. And that is why when we reach a point where remainder is 0, we will stop. So take a look at this and tell me if this will help in solving our problem or not. It will, right? we're able to get each digit of the original number one by one, starting from the first to the last. So this is the solution to our problem. But we have got some more problems here which we need to solve before we are able to implement this. And that is, given 1234, we're dividing this by 1000, right? So where is this 1000 coming from? As in, over here, we knew what we want as the quotient and we knew what we wanted as the remainder. And that is why we were able to figure that we have to divide by 1000. But given any random number, how would you be able to figure which number to divide that number with? So for that, let's take a look at what we have over here. We have 1234, right? And when we had that, we divided that by 1000. Now in the next step, we had 234 and 234 was divided by 100. Similarly, when we had 34, we divided that by 10, right? So when it was 34, we divided by 10. And when it was 4, we divided by 1. Now observe this. Do you see any pattern? In the first step, we're dividing by 1000. In the next step, we're dividing by 100. In the third one, we're dividing by 10. And finally, we're dividing by 1. So can we say that this 100 is 1000 by 10? We can, right? Now, if you're wondering, where is this 1000 coming from? I'll discuss that in a moment. But for now, take a look at this. Can we say this 10 is 100 by 10? We can. Similarly, this 1 is 10 by 10, right? So take a look at this. We needed 100. What did we do was we divided 1000 by 10, right? Now, where is this 1000 coming from? This 1000 is coming from the previous step. If in the previous step, we were dividing by 1000, in the current step, we would divide by 100, which is just what we divided by in the previous step divided by 10. And the same logic holds for these two as well. If we take this into consideration, we are dividing by 10. And this is coming from what we divided by in the previous step divided by 10, right? And the same thing holds for this as well. In this step, that is the third one, we were dividing by 10. So in the fourth step, we're dividing by 10 by 10, right? So to know what to divide the number by in the current step, you would have to know what you divided that number by in the previous step, right? If you know that, you can just go for that number divided by 10. So this solves part of the problem. The other part of the problem that is still unsolved is this. How do we know what to divide the original number by? Because if we know that, we can figure out what to divide the numbers by in each of the steps that follow that, right? So for that, pay attention to this and only this. This is 1234. And because this is 1234, we divided by 1000. Now, if it was, let's say, 1, 2, 3, 4, 5 instead, and you wanted to get the first digit, what would you have done is you would have divided by 10,000, right? And if you continue this way, you would observe a pattern. Or if you just come back over here and take a look at this, you would observe a pattern. If the number is a 4-digit number, we're dividing that by 10 power 3, right? Because this 1000 can be written as 10 cube. Similarly, if the number is a 3-digit number, we're dividing by 10 square, right? For a 2-digit number, divide by 10 power 1, and for a 1-digit number, divide by 10 power 0, right? So if the given number is an n-digit number, we're dividing that by 10 power n minus 1, correct? Now, this solves part of the problem, but another part of the problem remains, which is how do we determine the number of digits in a given number, right? So let's talk about that. There are two ways in which you can determine the number of digits in the given number. Let's discuss both of them one by one. So for that, let me take 1234 and divide by 10. Now, since this is the first time this division is happening, we will say 1. This is just keeping a track of the count of number of times the number has been divided by 10. And this will give me 123. It will actually be 123.4, but that 0.4 is not relevant for this case. So we will have just 123 and continue with this, which is we will take just the quotient and continue. Now we take 123, divide this by 10, and this will give me 12. And we have divided by 10 2 times so far. Then we take 123, sorry, not 123, 12. We divide by 10, we get 1. And the number of times the division has happened is 3. So we will update this to 3. And then lastly, we will take this 1 and divide by 10, which will give us 0. And the number of times this division has happened is 4. Now, once we have 0, we can stop, because this 0 over here indicates that we have taken all the digits into consideration, right? So the process to find the number of digits in a given number is divide that number by 10 continuously until you reach a point where the quotient is 0. And while you're doing that, keep a track of the number of times you have divided that number by 10. And the result at the end, which is 4 in this case, would give you the number of digits in that number. So this is one of the ways in which you can count the number of digits. Now, I had said that there are two ways. So let's discuss the second one. And the second way in which we can count the number of digits in a given number is by using log. So if we have a number, say n, and if we find log n base 10, that would give us an idea of the number of digits in that given number. Let's understand how. Now, since we're dealing with log n base 10, let's take numbers such that it would be easier to calculate this. So if I take n as 1, what would log 1 base 10 be? What would be this number? So if we assume that this is x, what does this become? This becomes 10 power x is equal to 1, right? Now, what will be the value of x such that you get 1? That value of x would be 0, right? So if n is 1, log n base 10 would be 0. Similarly, if we take, let's say, 10, this would be 1, right? Because this is what we have, log 10 base 10. And if we take this as x, we will get 10 power x is equal to 10, and x will be 1. Going by the same logic, 100 would give us 2, and 1000 would give us 3, and so on. So do you notice a pattern? N is 1, which is a one-digit number, and we are getting 0. So it is just log n base 10 plus 1, right? So if n is a one-digit number, we get log n base 10, and we find log n base 10 plus 1, that gives us 1, which is the number of digits in n. Going by the same logic, if n is 10, which is a two-digit number, we get 1 when we find log n base 10. And if we do this, we will get 2. Similarly, we'll get 3 here and 4 over here, right? So for the examples of n that we have taken, this seems to be working fine. But what about the cases when n is not 1 or 10 or 100 or 1000 or any power of 10? It is something else. For example, let's say I take a number between 10 and 100, right? If I take a number between 10 and 100, for example, 34, what are we going to get over here? That is, what will the value of log n base 10 be? It will be 1 point something, right? Now, 34 is a two-digit number, and we are getting 1 point something. So can we take just 1 from here? That is, we take just the integer part, we discard the decimal part, we take 1, and then we go for this logic here. That is 1 plus 1. That will give me 2, right? And if we take this into consideration, this seems correct. And if you go by the similar logic, if we take a number between 100 and 1000, let's say we take 700, we will get 2 point something. So we take just 2 and then add 1 to it, and that will give us 3, right? And this 3 is the number of digits in this number. So summarizing all of this, what do we know? We know that if we have a number, say n, and if we want to find the number of digits in that number, say d, we can go for log n base 10. And from this, we have to take only the integer part, right? We will get to how in a moment, but we will have to take just the integer part and then add 1 to it. This will give us the number of digits in the given number, right? So either this or this can tell us the number of digits in the given number. Now, once we know that, we can take the original number, find the number of digits, and determine what to divide that original number by. So if the number of digits is d, we divide the original number by 10 power d minus 1, right? That will give us a quotient and a remainder. Then we take that remainder and then perform another division. Now, to determine what to divide this by, there are two ways. Either you find the number of digits using one of the ways we just discussed and determine what to divide this by, Or you take whatever is over here, that is in the previous step, divide this by 10 to get what to divide by in the current step, right? So taking all of this into consideration, can we solve this problem? That is, can we take a number and can we now print all of the digits from the first to the last of the given number? We can, right? So there's a lot of things that we have discussed right now. Let's put each of them into code one by one. So for that, let's come to IntelliJ. And by the way, this is the code to extract digits from a given number from last to first. So let me copy the name of the class. Let me close this. And in the iteration statements package, let me create a new Java class. And let's name this class as extract digits from first to last. Here, let's have a main method. And in the main method, let's create a variable, say n, and let's initialize this to, let's say, 1234. Now, on the basis of whatever we have discussed so far, what is the first step after this? After this, the first step is to determine the number of digits that are there in the number, right? Now, we have discussed two ways in which we can get the number of digits in a given number. The first way is dividing the given number by 10 over and over until we reach a point where the quotient is 0 and we will stop. And every time the division happens, we will keep a track of the number of count the division has happened, right? That will give us the number of digits at the end. Or we can go for this. We can take the number, find the log of the number base 10, and then take just the integer part and then go for +1. Now, this is something which I'm going to cover when I'm solving questions on iteration statements, and more specifically, solving questions which needs us to extract digits from a number. If you take a look at the list of the question that I have, the second question says, given an integer n, count the number of digits in n. And there, I'm planning to go by this approach. For this video, what am I going to do is, I'm going to go by this. That is, find log n base 10, and then take the integer part of it and then go for +1 to get the number of digits that are there in the given number, right? So with that, let's come back to IntelliJ and let's find the number of digits in n. And for that, we know that we'll have to go for log n base 10, right? Now, how do we find log n base 10? For that, we have a math class inside which we have got a method called log10. So if we take a look at the implementation and the documentation of log10, it says returns the base 10 logarithm of a double value. Now, what it means is if you give it a number, it will treat that as a double value and it will return the log 10 of that number. Now, this method is in the math class. We have not discussed about classes and methods yet, and that is why I'll not get into the details of it. But just understand that if you pass a number to log 10, it will return the log 10 of that number back to you. So let me demonstrate that first before further implementation. Let's say I pass 10 to it. Now, on the basis of whatever we have discussed, what should be the expected output? It should be 1, right? So if I just print the value, what do you think will happen? It should print 1, right? And let me change it to current file and run. It says 1.0 and it says 1.0 because it is returning back a double value. Similarly, if I say 100, it should give me 2.0. And if I say, for example, 18, it will give me 1 point something, right? So whatever we get will be a double value. And what we have to do is we have to take just the integer part of it, right? And we know that we can do that by typecasting it to int. So if I typecast it to int, I'll get just 1, right? But if I remove this typecast, it will be 1 point something. So let us typecast this to int. And let me grab this because we will need this. Let's get rid of the println and let's put it here. Now, instead of passing 18, let's pass n to it. So this will give us some value which when typecasted will give us the integer part of it. Now what we have to do in order to get the number of digits is go for a +1 and we will store this in a variable called, let's say, digit count. So if I print digit count for n is equal to 1, 2, 3, 4, I should get 4 and that's what I got. If I change this to, let's say 8901223, I should get 6. And that is what we have. So this code seems to be working perfectly fine. Now let me change it back to 1234 here as the value of n, and let's continue from here. But before that, let me get rid of the println. Now let's come back to whatever we had discussed. So on the basis of whatever we had discussed, we would need the number of digits which we have. Then what will we have to do is we'll have to divide the given number by 1000. Take the remainder and divide that by 100. Then take the remainder from there, divide by 10 and continue. So now, given that we know the value of n and we know the number of digits that are there in n, and on the basis of that, we can figure out what to divide n with. What's the next step? As in, how can we solve this? So for that, let me first of all clear this and start with the value of n, which is 1234. So when n is 1234, we know the number of digits that are there in n, right? That will be 4. Now, the first step that we had discussed was n, which is 1234 will be divided by 1000. And this 1000 is coming from 10 power digit count minus 1. So let's say we have a variable called divisor where we are storing this, that is 10 power digit count minus 1. So this will become 1000. Now we will get to how to solve this in a moment, that is 10 power digit count minus 1. But for now, let's just assume that we know this. So if divisor is 1000 and n is 1234, we will get a quotient and a remainder, right? The quotient would be 1, remainder would be 234. So this will give us 1 and 234. Then according to whatever we had discussed, the next thing would be processing 234, as in dividing this by a certain number, which is 100 in this case, to get 2 as a quotient and 34 as the remainder, right? So in a way, whatever was done with 1234 has to be done with 234 in the next step, right? Now, all of the logic that we had discussed and all of the operation that we have discussed, that is counting the number of digits or calculating the divisor, then finding the quotient and remainder, is being done on the value of n. So this remainder, which is 234 here, would become the value of n in the next cycle, right? Because we have extracted the first digit, it will reduce to 234. So if we reduce this to 234 and then proceed, let's see what happens. Now, when we have 234, we need not count the number of digits in this. Why? Because the reason we were counting the number of digits was to get the divisor. But as we have discussed, there are two ways in which you can get the divisor. First, of course, by counting the number of digits. And the second way was taking the divisor that was there already and then dividing that by 10 to get the new divisor, right? So we will skip this. Over here, the divisor would become 100. And if divisor is 100, quotient is going to be 2, remainder is going to be 34. Then this 34 would be the value of n for the next cycle. No need to count the number of digits. Take the divisor as 10, quotient is 3, remainder is 4. And then over here, n will become 4 next. And then what's going to happen is this will become 1. And then quotient will become 4 and remainder will become 0. And by the way, I have crossed all of this out because we are using the same variable to store subsequent values. So if you put, say, 4 over here, this 34 will be overwritten, right? So crossing all of this indicates that the value is getting overwritten. Now, remainder is 0, which means if we take this 0 over here, what's going to happen? N will become 0. And like we have discussed, when n becomes 0, we will stop, because that is an indication that we have extracted all the digits of n, right? So taking this into consideration, what would be the code for this? Let's discuss that. So now we have int n, which is 1, 2, 3, 4. Then we have counted the number of digits, which is 4. Then the first thing that we have to do is calculate the divisor. Now, as we know, this divisor is 10 power DC minus 1. So again, there are different ways in which we can find 10 power DC minus 1. But over here, what am I going to do is I'm going to use a method of the math class itself. the one that we just used to calculate log 10. Now, in the math class, there's another method called POW. This POW takes two values, say x and y. So when you pass POW the values of x and y, it is going to calculate x power y and is going to return it back to you. So if we take this into consideration, how can we find 10 power dc minus 1? Can we say math.pow 10 comma dc minus 1, right? So this is going to give us the divisor. And by the way, similar to the log 10 method, this will give us a double value. So we'll have to cast it to end. But let's keep that for the time when we are writing code in IntelliJ. For now, let's just consider this statement and move on. So we've got divisor, right? So we have n, we have digit count, we have divisor. The next thing to do is calculate the quotient and the remainder. Now to calculate the quotient and the remainder, what will we have to do is we will have to divide n by the divisor. This will give us the quotient. For remainder, let us say I'm storing it in a variable called rem, and this is n and not r. So remainder would be n mod divisor, right? So when we do this, we are going to get 1 in quotient and 234 in the remainder. Now, what did we discuss over here? We discussed that the remainder would become the value of n for the next cycle, right? Which means, first of all, that this will repeat for a certain number of times. And that is something we have discussed here already, right? This will repeat as long as the value of n is not equal to 0, right? And that means this is going to be in a loop. So let's put it in a loop. That loop can be a while loop with the condition n not equal to 0, right? Because what we want to do is we want to keep on calculating the quotient and the remainder and then putting the value of remainder back in n for a certain number of times. And that would be determined by the condition that n is not equal to 0, right? So we can say this: while n not equal to 0, calculate the quotient, calculate the remainder. So with this, we will get 1 and 234. Now, the next step is to take this value and put it in n, right? Now, how can we do that? At the end, once we have the remainder, can we say this? Can we say n is equal to rem? If we do that, what's going to happen? Rem, which is 234 in this case, assuming n is 1, 2, 3, 4, and this is the first iteration, n will become 234, right? So that takes care of this. The other thing that we have to take care of is changing the value of divisor, right? Because we know that when n is 234, the divisor has to be 100. But if you take a look at whatever we have over here, what did we do was we started with n is equal to 1, 2, 3, 4. Q will be 1, rem is 234. Now n has become 234, but we have not changed the value of divisor. So if we end the loop here, what is going to happen? In the next iteration, divisor would still be 1000, right? So either we can calculate the number of digits in n and calculate the divisor every time, which will be expensive because there will be more calculations involved, or we can calculate the value of divisor in the loop at the end so that when the loop iterates the next time, it has got the correct value of divisor, right? So the second one sounds better to me, and that is why let's go for this statement. We'll say divisor is equal to divisor by 10. So what's happening over here is the current value of divisor is being taken and that is being divided by 10, and the result is stored back in the same variable, which is what we have discussed that we will have to do, right? Take the current value of divisor, which is 1000 in this case, assuming we are in the first iteration. Then we are going to divide this by 10, which will give us 100, and we will store that back in the same variable so that when the loop iterates for n is equal to 234, divisor has got the correct value, right? So with this, we can then end the loop. Now, before I put this in code in IntelliJ, I want you to pay attention to these two statements. Over here, we have got n mod divisor, which means divide n by whatever value is there in divisor and collect the remainder, right? Then we are storing that remainder in a variable called n. So can we not do it this way? Can we say n is equal to n mod divisor? In that case, what's going to happen is n will be divided by divisor and that value will be stored back in n, which is what exactly we are doing right now. We are calculating the value of remainder and storing in REM. And in the next statement, we are storing that back in N. So instead of these two statements, we can do this with just one statement, right? Like how we are handling over here. That is dividing divisor by 10 and storing it back in the same variable. So with this change in place, this is what it is going to look like. We will say N equal to N mod divisor, and we will get rid of this statement. So this is the code that will help us in getting the digits of a given number from the first to the last. So with this understood, let's go to IntelliJ and let us implement this. So with digit count in place, what will we have to do is we'll have to calculate the divisor. And we know that this will be calculated using the POW method that is there in the math class. So we'll say math.pow. Now let me first of all go to the implementation and documentation and show you what it says. Pretty long documentation. It says that it returns the value of the first argument raised to the power of the second argument, which is essentially saying that if you pass x and y, it will go for x power y and then return that back to you. Now, if you take a look at the method itself, it is taking two values and both the values will be treated as double. And the value that it returns back is also double, right? So similar to what we did with log 10, what will we have to do here is we will have to pass the two values, the first one being 10 and the second one being digit count minus 1. Then this will give us a double value back. So what are we going to do is we're going to put this in a pair of parentheses and I'm going to say int. That is, this is being typecasted to int. So if I just print the divisor now and run the code, what do we expect? Well, digit count is 4. So divisor should be 10 power 3, which is 1000. So if I run the code, I expect 1000. And that's what we are getting. Now, if I change this 1234 to 234, we should be getting 100. And that's what we have. So it seems to be working absolutely fine, right? So let me revert it back to 1234 and let's continue with the code. So we've got digit count, we've got divisor. The next thing we have to do is run a loop, and that loop will be while n not equal to 0. Then over here, what are we going to say? We're going to say int first digit is equal to n divided by divisor. Then we will get rest of the number. For rest of the number, what will we have to do is we'll have to go for n mod divisor, right? And then we know that we have to store it back in n. So when n is 1, 2, 3, 4, after the first digit has been extracted, n will become 2, 3, 4. And because n is 2, 3, 4, and we want divisor to be 100 when n is 2, 3, 4, what are we going to do next is we're going to update the value of divisor with this operation. That is, take the current value of divisor, divide that by 10, and put it back in the same variable. Now with this done, we have the first digit, we have the value of n ready for the next iteration, and we have the value of divisor ready for the next iteration. So let's print the value of first digit over here, and let's print it in one line followed by space. So with this done, if I run the code, what do we expect as the output? We should get 1, then 2, then 3, and then 4 as the output, right? All of them in one single line separated by spaces. So let's run the code, and that's what we have. Now, if I change it to, for example, 76193, I should be getting 76193. So if I run the code, that is what we have. So this is how we can extract the digits from a number from first to last. So with this, we've come to the end of the video. Summarizing, we talked about how can we extract digits from a number from the first digit to the last digit. I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.